So when you think of climate change and the greenhouse effect, you probably think about carbon dioxide emissions. However, there is another greenhouse gas that is abundant, more potent, and difficult to get rid of. Methane is the second most abundant greenhouse gas after carbon dioxide, and it's 25 times more potent than carbon dioxide. However, it's also shorter lived, as it only exists in the atmosphere for about 10 years compared to the hundreds of years for carbon dioxide. Because of this, focusing on reducing methane emissions would have a more immediate impact compared to carbon dioxide mitigation efforts.
Reducing methane emissions is key to staying on track to meet the goals of the Paris Agreement by 2050 and keep warming below 1.5 degrees Celsius. It is vital that we reduce methane emissions as soon as possible, as reduction of their short-lived presence in the atmosphere will have a nearly immediate impact on climate. Agriculture is the leading source of methane emissions globally, and most of these emissions come from livestock and food waste. Another important source of methane emissions is from the oil and gas sector during fuel consumption and leaks from fracking activities.
Agriculture, particularly animal agriculture, accounts for 14 to 18% of global emissions. Beef cows are responsible for 41% of agriculture's greenhouse gas emissions, while dairy cows are responsible for another 20%. Pig meat is responsible for 9%, buffalo milk and meat is responsible for 8%, and chicken meat and eggs responsible for 8%. Small ruminants, which includes goats and sheep, their milk and meat is responsible for 6%. The ruminants, including cattle, goats, and sheep, ferment their food in their stomach before digesting it, and this is what creates methane gas and emissions. Each year, a single cow belches 220 pounds of methane. Additionally, the decomposition of livestock and poultry manure in anaerobic conditions, such as liquid or slurry in lagoons, ponds, lakes, or pits, produces methane. Methane emissions from animal agriculture are significant and greatly contribute to global warming, so implementing innovations in farming is imperative to reducing these emissions. Increasing herd efficiency is the most promising solution to reducing the emissions associated with ruminants, particularly cows. This would involve using better feeding techniques to reduce the methane generated during digestion, as well as the methane from decomposing manure. Currently, farmers are experimenting with feeding cattle seaweed and have seen emission reductions in a single cow by up to 92%. Though effective at reducing carbon emissions, this solution has environmental and economic challenges and may be difficult to scale up to the different ways of producing livestock. Improving breeding will allow herd size to shrink and result in fewer, more productive animals that consequently produce less emissions. Additionally, better grazing land can increase livestock efficiency while creating carbon sinks, essentially sequestering carbon in grassy fields. Although it's important to change food, business, and government policies, especially in wealthy countries where people eat a lot of beef, you as an individual can still play a valuable role in the transition to a lower methane food system. Reducing worldwide beef consumption by just 20% by 2050 would reduce methane emissions by 11%. You can be a part of this reduction in meat consumption by partaking in Meatless Mondays, opting for alternative proteins such as Impossible or Beyond Meat, or simply eating meat as a side dish rather than a main course. Each time you reduce meat consumption, especially beef, you're reducing methane emissions and helping our climate.
Another major source of methane emissions is decomposition in municipal solid waste landfills. Emissions from landfills, or landfill gases, typically consist of about 50% methane and 50% carbon dioxide. Landfills are currently the third largest contributor to methane emissions in the U.S. after agriculture and energy, accounting for 14.5% of emissions in 2020. So how does this work? Most of the content of landfills is organic material, such as food waste, which is eventually subject to biological decomposition. When oxygen is available, aerobic decomposition will occur. Decomposition via the consumption of oxygen is the most energetically favorable pathway. However, once the oxygen for decomposition is depleted, methanogenic or methane-producing bacteria become the dominant decomposers, releasing methane through a chemical process called methanogenesis. In landfills, the aerobic conditions that facilitate this process are generally established in less than a year. A developing area of climate research focuses on how landfill methane emissions can be captured and utilized as an energy source. Methane from landfills is captured by small perforated tubes that stretch vertically downwards into the waste, which collect the gas and direct it to a central collection facility. Once collected, methane gas can be compressed, purified, and used for fuel, or it can be burned to generate electricity. Unfortunately, this solution is only efficient in closed, engineered landfills and is unfavorable for open dumps, which constitute the majority of landfills worldwide. The best way to help minimize methane emissions is to produce less organic waste in our daily lives. You can help by shopping and storing your food strategically so that you can minimize the amount that goes to waste. So now that you understand the major sources of methane and how it impacts climate, we hope that you can make connections between your daily habits and how they might contribute to methane emissions. We can all work to reduce methane in the atmosphere by eating more plant-based foods, advocating for research into reducing ruminant methane emissions, working towards improved waste collection methods, and keeping our individual food waste to a minimum.